Hello everyone. Now in this lecture we will know about the inference rule under the relational database design. Then Armstrong's NCM are the basic inference rule. That is, Armstrong NCMs are used to conclude the functional dependency on the relational database. That one is a inference rule is a type of assertion. It can apply to a set of the functional dependency to try other functional dependency. Using the inference rule, we can derive additional functional dependency from the initial set. For example, we have some functional dependency set of a particular table. Then we can write the new functional dependency or the additional functional dependency with the given set. Right? Then we will know about this rule. The functional dependency has a 6 type of inference rule. Reflexive rule. In the reflexive rule, if y is a subset of x, then x determines y. We can say that this symbol says that is used to set theory to say that x is a superset of y. All element of y are contained with the x. Right? Means if y as a set, which one is again a subset of x, means the x is superset in the respective of y, then we can say that it's a reflexive rule. That one is x determines y. That is simply the first rule of the reflexive rule. Now the example, like x is a b c d e and the y is ABC, means the y is a subset of ABC, subset of x. Then we can say that a reflexive rule satisfied. Then the argumentation rule. The argumentation is also called the partial dependency. In argumentation, if x determines y, then xz determines yz for any z. If x determines y, then xz determines yz. That is simply the example for a relation with the ABCD. If A determines B, then AC determines BC. That one is simply the rule as a argumentation rule. Now the third rule, that one is a transitive rule. Transitive rule, if x determines y and y determines z, then x must also determine z. X determines y, y determines z, then we can say that x determines z. Then fourth rule, that one is a union rule. Union rule says if x determines y and the x determines z, then x must also determine y and z. That one is x determine y, x determine z, then combinedly we can say that x determine y z. Then as a proof how exact these two are the given relation, now we apply the rule 1 and 2 and we get the we apply the that one is rule 2, that one is get the this situation that x is yz. Why? Because of x is the xy, we can say that x determines xy because of now this one is a given and we can say that it's adding with again itself by x is allowed. Now the xy determines yz, xy determines yz. Because of x determines z, we can add the y in that with the rule of argumentation, right? Now the output, that one is we can say that is x determine yz. Then decomposition rule. Decomposition rule is also known as a project rule, result of a union rule. This rule says x determine y and z, then x determine y and x determines z separately. If x determine yz, then x determine y and x determines z separately. That one is simply the decomposition rule. Now the last rule, that one is a pseudo-transitive rule. If pseudo-transitive rule, if x determine y and yz determine w, then xz determines the w. This one is x determine y, yz determines w. Then it's a common thing with x and yz. That one is simply the xz determines w. How exact it possible? Because of it replaces y with the x, right? Xz determines w. Now these are the some inference rule which one is used at the time of a functional dependency, or it may be rules are important at the time of to check the given functional dependency in which in which normal form. It may be exam contain a question in a given relationship or the given functional dependency or the given relation. Find out the particular relation in which normalization form. It's in 1NF, 2NF, 3NF or the BCNF. At that time we need this type of these rules to identify the situations. Thank you.